Okay, so hello everyone. So at first, I'd like to ask you all if anybody of you have any doubt in the week 10 content, anyone, or is it clear to all?
Ma'am, week 10 content means that concurrency, right?
Yeah, the serializability part and all
Correct,
this.
correct, correct. So one thing is, like if you can once again explain that view serializability. Okay, that
Oh,
is one thing. And
okay.
secondly, one thing like I asked quite some time back in one of the lecture, like one of the session that say for example, you are withdrawing a money from SBI and you are depositing then in that in ICICI, right?
Okay.
Now, in that circumstances, you do not have the transaction at the same place, right? Now, that time, like I was being told that your two-phase locking mechanism will help in that. If you can explain that part also, like it will be helpful.
Okay. So, Subhendu, would you like to volunteer?
Yeah. Pradeep, can you take views reliable?
Yeah, sure. Am I audible?
Yes, yes,
Up to conflict serializability is clear to everyone.
yes, yes,
So, this is my screen is visible.
yes, visible.
Yeah. So, so suppose there is the domain of the serializable schedule, right? This square bracket is square. You can assume this thing as the numbers of serial schedule. Right? This is the non-serial schedule. Everyone knows what is serial schedule and
Sir,
the
your voice
non-serial
is little
schedule.
bit faint. Like not sure if it is only for me.
Okay.
Hello, sir.
Yeah. Wait a few minutes. Wait 1 minute.
Okay.
I think some networks.
Hello. Hello. Hello.
Yes, Pradeep, you are audible.
Yeah. Am my voice is clear also or not?
Yeah, now clear.
Yeah, now it is clear.
Yeah. So let me explain again. So suppose you know about the schedule is possible. Two type of schedule is possible, right? One is serial schedule, and one is non-serial schedule, right?
Yes.
So in serial schedule means first complete one transaction, then start the next transaction, right? So in this way, we schedule, that is the serial schedule. And we assume that the serial schedule are always consistent in the database. And we want a schedule that should be consistent, right? But why we prefer the non-serial schedule? Because of the throughput or the performance of the database increase if we design the non-serial schedule. So first we try to, so that's why we prefer the non-serial schedule, because of the throughputs or the performance. It will increase the performance of the database. So in non-serial schedules, we concurrently execute two or more transactions, right? So in that way, so suppose there is the big numbers of non-serial schedule. In the non-serial schedule, some of the serial schedule are the serial schedule, right? Up to this is clear.
Yes, yes.
Yeah. So in the non-serial schedule, how we say that the non-serial schedule is a consistent or not. So that's why we try to make the equivalent to the serial schedule. So there are two things there are two notions, right? One is the conflict one, conflict serializability. And the second one is the view serializability. Okay, so you all know that those conflict serializability are also view serializability, right? You know.
Yes, conflict serializability is the tighter constraint and view serializability is the like more generalized one and lighter one.
Yeah, weaker
Correct,
form.
weaker one. Yes.
Yeah. So now I can say this one is the non-serial schedule, and some of the non-serial schedule. Okay. And some of the there is a sum of that are the serial schedule. Okay. And here, so some of the serial schedule can be possible to prove that as the serial schedule using this view equivalent, means this view serializability, right? Okay. Serializability using this one, and as I said, the some all the conflict serializable are the view serializable. Can I write here? So this conflict serializability here, is this Venn diagram is clear to everyone or not?
Yeah, the innermost circle you are saying conflict serializable. The triangle you are saying view serializable.
Yeah.
Yeah, perfect.
Yeah. Okay. So I'm here only discuss about the what is the view serializability here, right? So first we say, so which of the what is view equivalent? Before we discuss about the view serializability, let's see what is the view equivalent. So suppose there is two transaction, one is the two schedule, one is the S and another is the S dash, and it consists of the two transaction, one is the TI and TJ. Okay, so this condition 3 condition, there is a for the view equivalence, this S and S dash should be we call as the view equivalent if it follows the 3 condition. So first condition, what is the initial read? So what is initial read? So suppose this is the schedule S and this is S dash. Okay, and transaction TI and TJ, it has the also transaction TI and TJ, and this also have the transaction TI and TJ. So first condition is the initial read. So suppose a data item has the queue. If the first read operation done by TI on that data items, then that also the first read operation on that data item should be done by the same transaction. So suppose TI performs the read operation on the queue in S, right? So S dash also perform the first read operation on the similar data items. So that is Q. So it should be first read operation performed by this transaction. So
sir, here the confusion is okay. Now,
yeah.
say for example, the in S, my first transaction is RQ. Okay. But
Yeah.
S dash, it may not be necessary that it starts with RQ, but whenever there is a read queue, that should be the that should be the kind of first statement in the entire hierarchy. Not necessarily RQ is the first one.
Yeah,
Is that
here maybe RB possible before
right?
that. Yeah, right be possible. Yeah. But whenever come to this particular
Queue.
data items, so we consider only this data item.
Okay. So like positionally RQ can be anywhere, but whenever
Yeah.
you are working on queue, that RQ is the first statement.
Yeah. So for to clear your confusion, so okay. So this is TZ, right? TJ. So this is not possible. RQ is not possible before come to this, right? So suppose here in this transaction, RQ and RQ here. So this is not possible. So I think it is clear now what is not possible.
No, sir. Can you take a like white page and say like
Yeah. Okay, just a minute.
hard to follow it.
This white phase is visible.
Yes, sir.
Yeah. So suppose there is S and S is TI, TJ, again TI, TJ. Okay. So first read operation if data item. So suppose schedule is like this, RQ and RQ, right? So here you can see the same data items, and here one is RB, right? So first condition is what? It should be initial read condition, which checks the initial read condition. So what is the initial read condition? If the data item, here you can see data item Q is first read operation is performed by the TI. So it should be same as in S dash also. So first read operation on this data item Q, read operation performed by the TI, right? So reverse is not possible. So I'm talking about this condition, right? So here you can see the first read operation is performed by TJ, right?
Okay.
Yeah. So similar thing here, RB and RB, this is not possible because first on the data item B, first read operation is performed by the TJ, but here S dash is you can see S dash is on the data items, it's performed by the TI. So that is not the initial, it not satisfy the initial read condition S and S. So the point is, if S the first performs the any data items TI, then it should similar to the S dash also same on the same data items, the same transaction should first performs the read operation. That is the initial read condition. So that is the first condition is the initial read condition. Okay. Initial read condition is clear to everyone, right? Yes or no?
Yes.
Yes. After
Right.
that,
Read pair.
Yeah, right here. So before discuss about the right read here, I want to discuss about the final write. What is the final write? So suppose TK. So suppose S is the schedule with 3 transactions TI, TJ, TK, and S dash also the same transaction. We said these are the equivalents of the same transaction. It has also the same transaction TIT, and suppose the schedule is like this. So here you can see. So here you can see which of the transaction performs the final write.
TK.
TK performs the final write. So
Yeah.
it should also the final write by the TK also in S dash. So here you can see I changed the order of here. It doesn't matter, but final write should be done by the same transaction on the same data item. That is the final condition. So here you can see 3 transactions. TI, TJ performs the write operation on this data items queue, but the final write operation done by the TK. So it should also on the same data items, final write should done by the TK. Before that, it may be any order on the write operation. Here you can see the 2 write operation are there, right? Is this clear? What is the final write?
Yes, yes. But sir, like now say for example in S prime, your TJ is TJ like it is initiating the WQ first. Okay.
Yeah.
Now say for example in original schedule S, okay, this WQ does some before this WQ. Okay, TI performing this WQ. Okay, it like it performs certain calculation on Q and then write a WQ. Okay.
Yeah.
And in S prime TJ you have taken WQ first, so shouldn't it be like problematic?
No. So let me tell in this way. Suppose Q is 100, 200, right? In the this is how we read in the database. So suppose this is the your original database, right? Yeah. We bring that data into our local buffer. That is the main
Buffer,
memory.
huh.
Yeah. So suppose this is the main memory, right? So here Q equal to 200, right? And we perform so this right. Suppose this is the is minus 50 and this is also minus 50, means we perform this operation. Whatever's the balance up to these 3 are suppose the minus 50 or you can say minus 40.
No,
right?
sir, instead of that, like you take the first WQ as 10% of WQ and second one you take minus 50.
So
the first WQ in S you take 10%.
Okay.
Or for the calculation easy like 50%.
Yeah. So you want to say if I perform first 10% and the second after that the 10% that's will different.
The first WQ, that means WIQ in S, okay, take that as 10% of Q.
Means you means Q minus 10% of Q.
Correct,
right?
correct. Yes, that is the first WQ operation. Okay, and the second WQ is Q plus or Q minus 50. That is okay. One is percentage, another is minus. Now if you change that order.
Okay, I got your point. What you exactly want to say. Yeah. So suppose this is a 200 and 10% of 200 is 20. Okay.
That means this will be 180.
And this is 180.
And
Okay.
then minus 50 is 130. Now after Tj, your Q is 130. But if you
So
do it in a
this
reverse way, it will be different.
This is 150 and this is this is 80 minus 50, 150. So 150 minus 15, that is 135. And
Correct.
we write something here, suppose the minus 50. So here 100 value and here minus 50 means 80, only 80.
80.
Right?
Yeah. So both are different now.
So here you can see, here we write the value. So this operation, whatever you told this operation, here we not performing any operation. Direct value, right value. Means whatever's right Q means what? Suppose I want to write into the data this value. Suppose I want to write 100. Here, suppose I want to write 50. That is the right operation, right? And here, right operation. And whatever you told me, that is the Q minus. That operation is like you have to define, right, some operation, right? That is the suppose Q equal to Q minus 10% of Q, right?
Correct. And then WQ.
Yeah, but here you can see that is not defined here. Only it is defined, you have to write Q. Means whatever's value, I want to directly write into that. So I think you misunderstood this thing.
No, but sir, whenever you will say write WQ, right?
Yeah.
Of course, before that, it is kind of implicit, right? You need to read that Q and do some operation, and then only you will go and write Q. Otherwise,
No,
like
that is if you see in the schedule, that is explicitly given to you. Suppose you have to write. So yeah, let me clear your confusion. Yeah. So suppose the schedule is you have to transfer 50 rupees from account A to account B. So what are the transaction? First you have to read A, then you take this minus this one. This is A minus 50. Here you can see I have write this operation also. Then write Q. Right. So these are different operation, right? I here define only this one, right? Q. So that I supposed to want to write some value. So suppose that value is 100 directly. That's why this view serializability is we take this. You got my point. Whatever you told operation, that is you impose that into the schedule. But I write first only the right operation on the queue. Are you getting this point or not?
yes, sir, I'm getting that point. Only thing, like my question was, when we discuss that final write, right?
Yeah.
Final write, like you have not changed the position of TK.
Yeah.
TK in the schedule S and S prime is same.
Yeah. Okay.
Okay.
Let me first complete the example. Then I think it will be clear to you.
Okay.
Yeah. So yeah. So right queue. So what this operation means, I want to write some value that is the 50. Okay. Here I want to write some value 100, and here I want to write some value 50. And this is the value in my local buffer. So it will change the value in my local buffer, that is changed to 50, right? Second, in this operation, it changed the value into the 100. Then it changed the value of 50. So my final value is the 50 according to S schedule. Similar for this S dash. Okay. So initial value is 200. So this operation is write value 100. This is 50, and this is also 50. Here you can see I have changed my whatever's the value of the queue in the buffer. So I change the value to 100. Then again by T1 operation writes the value into the 50. And then by the TK, its value got changed into the 50. So that's why we consider only the final write, right? Here you can see whatever you have changes. So here you can see the change of this order of the value right before that. But if we consider only the final write operation, then the value is same on the local buffer. Here you can see here it is 50, and it is also S is also 50. I think now it is clear to you. This write means we directly write some value into the local buffer. Hello.
Yeah, so that means the previous operations we are not taking care at this point of time.
Yeah.
Assuming when you are writing about the, say for example, the WQ equal to 50, till that point my database is in consistent state.
Yeah. Write
Okay.
queue means we want to write some value into the queue, and that value is the 50. Here you can see 50 and 100, and so whatever's before the changes on the right values, that doesn't matter to us. Only
Okay.
we consider the final value.
Okay. Okay.
So yeah. So now the next is write read pair. So write read pair means, so it's clear. So yeah, this is the write operation. So let's initial read condition is clear. So I don't. So this is RB data items. So here you can see this is the whatever's value written by the TJ, that value is read by the TK. So it is not reading the initial value whatever's in the database. Means what is the Q of value? Suppose Q is 200. That value is not read by this array. So this is not initial read. You got it?
Right.
Yeah. It reads the value that is written by the TJ, right? Okay. So suppose its value is changed to 100, and so it reads the value that is array. This value is 100. reads Q value is. So this read write read pair should be maintained in the S dash also. So that this is the point. So 3 point is clear. If these three condition is satisfied, any S or S dash, then we can say the S and S dash are the view equivalent, right?
Okay, so all these three conditions have to be satisfied, or like some of these?
No, all three conditions need to be satisfied. You first consider the schedule, then check for the all three conditions are satisfied or not. If all three condition is satisfied, then we can say these
Okay.
two schedule are the view.
Okay.
So yeah, let me tell you. So here, so tell me, consider the data item B, whichever performs. Okay. This is clear, right? It is visible. Yeah. TIRB, RA, and R. Okay. So suppose consider S and S dash. So in S, B is the we consider the data items. Which transaction performs the initial read? That is TI, right? In S,
Yes.
S in S dash on the data item B, which is performs the initial read on the data item B.
Same RB, TI.
Yeah, TI, right? So now consider the A, data item A. This is the initial read condition. So here you can see once the data items no initial read condition. This is not initial read condition because it first performs the data items right. So that is not original value of the. If this is readings, though it is read the data items A, but this is not initial read. So in the
Right.
there is no initial read condition.
In the TK, right? Because it is a write read pair condition.
Yeah.
Yes.
We can say no initial read condition on data item A, right?
On data item A, right?
Yeah. So now we check for the final write. So final write on the data item B, no final, no write operation.
Right,
So,
only on A.
Yeah, A, and that is performed by the TZ. Right.
Yes.
Once the data items S dash on schedule S dash, it is also performed by the final write performed by the TJ. Right. Okay. Now we look for the read write pair. Not
read pair, right?
Write read pair.
Yes.
So there is only one write read pair, that is the TJ to TK.
TJTK, right?
Yeah. Whether it performs this TK read the data item that is written by the TJ or not. So here it is present, right?
Yes.
Yeah. So we can say the write read. I just write the maintain, right? So it is maintained. Okay. So we can call the S and S dash are the equivalent, and also you can see these are the serial schedule, right? First is complete TJ and TK, then TI. Means TJ then performs TK, then TI. So we can also call this is the view. This S and S dash is the view equivalent, and S dash is also equivalent to serial schedule, right? So we can say that this is the view serializability, because this is the equivalent to serial schedule, right? View equivalent. So that is the view serializability.
Correct.
Is it?
Yes.
Yeah.
And sir, like for that schedule S, if we draw the precedence diagram, in that case Ti connected to Tj and Tj connected to Tk, right? So that is no cycle.
Yeah. So yeah. So that whether the serial is a view equivalent or not. So
Yeah, in that same diagram, like Ti Tj
yeah.
is Wa and
I understand your concern. So yeah. So first you want to check the whether the schedule is a view serializability or not, right?
correct.
Yeah. So as I say, all the conflict serializable are the view serializable, right?
Right.
Yes, sir. Okay. So first we check for, so if we check for the conflict serializable and we get the schedule is a conflict serializable, then we can say it also the view serializable, right? First, if we asked whether the schedule is a view serializable or not, so first we can check for the view conflict serializable. If it is a conflict serializable, then we can say the schedule is also the view serializable. So that's why you want to draw the precedent graph, right?
Uh, sir, all view serializables are conflict serializable, right?
No,
But
all the
it is a
conflict,
reverse way.
all the conflict serializable are the view serializable.
Okay. Yeah, but the converse is not true. Understood.
Yeah.
Okay, perfect.
Yeah. So if I asked whether the schedule is a view serializable or not, you can first check the conflict serializable or not, right?
Yes.
Yeah.
If it
If
is
it
conflict
is,
serializable, then it is view serializable as well.
yeah,
Right.
right. Then we can say it is the view serializable also. If it is not, so at least there should be present one blind right. So what is the blind right here? So this is the blind right. So without read A, it performs the right operation. That is the blind right. So if some schedule is a conflict serializable and have the blind right, so no, the point in this way, the if any view serializable, so VS means any view serializable.
Hello.
Yeah. So
Okay.
any view serializable, any schedule, okay, any schedule that is view serializable, right? Any schedule that is view serializable but not conflict serializable. CS means conflict serializable, but not conflict serializable. It should have at least one blind right. Right. So here you can see the next point is if the that is not conflict serializable, we check for the whether the blind right is present or not. If blind right is present, then we go for check for the view serializable or not. We need to check for that. If blind right is not present, then we can directly say this is not view serializable. This point is clear.
No, sir. Can you give an example actually for this blind right stuff?
Yeah. Okay, let's check. Okay, let me check in the slide. There's one.
Yes, yes, it is there, but forgot actually, blind right.
Is it visible, right?
Yes, yes.
Yeah. So first we check for the conflict. We have to check for this is view serializable or not. VS means view serializable or not. So
Mhm.
first we go for check for the conflict serializable or not. So we try draw first precedent graph.
Hmm.
Okay.
So
So
T27 to T28.
yeah, there is one arc should be there.
Hmm.
Okay. So
Then
after that, here to here also.
T28 to T29.
No, first we check for this one. So
Okay,
here read write conflict. This is
right.
also read. Yeah,
And 27, 29 also. Yes.
yeah, yeah.
Hmm.
So after that we go for this. So this is the right conflict.
Yeah,
So
28, 27. So it is already there.
yeah, no.
Oh, sorry,
Here
sorry,
you can,
sorry, sorry, sorry.
yeah,
It is reverse. Correct.
yeah. T28 to T27.
27. Yes, yes.
Yeah. So now we check for this one, and here to here also. But
T28 to T29, right?
yeah. And T27 to T29, that is already present, right?
Already present. Yes,
Yeah.
yes.
But here you can see the cycle is present. So this is not the conflict serialized.
Not conflict serializable, right?
Yeah. So what is if view serializable, first check for the conflict serializable or not. If not, then we check for the blind write present or not. It is not conflict serializable. Then we
Hmm.
check for the blind write present or not. So you told me, you tell me what is blind write is present or not.
So that's yes, the T28 right queue is the blind right?
Yeah, this is the blind write, and this is also blind write.
Which
So
one?
without this T29, because
T29.
without performing the read operation on the queue, it performs the write operation.
Okay,
That is
okay,
the
okay, okay.
definition. That is the definition of blind write, right?
Yes, 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 yes.
Yeah. So this two performs the blind write, but this is not blind write because it first performs the read
Read
operation,
and then
read
write.
then write. Okay. So
Okay.
yeah. So blind write is present. Now we go for the check for the
View serializability.
view serialization. If blind write is not present, then we directly say this is not view serializable. Okay. Okay. So now check for try to draw. There is how many possible is possible means there is 3 transaction, right? So
Hmm.
permutation, how many permutation is possible? That is the 6 permutation possible, right?
6 permutation, yes.
Yeah. So here we can eliminate those things. How this is? So here you can see the final write performed by the T29.
Yeah, it will be T27, 28, 29.
Yeah. So we can arrange in this way. So
Yeah, because the initial read,
T27.
final write. Yes.
Yeah. In this way we can eliminate. So no need to check for every
Right,
permutation,
right,
right?
right. Yes, yes.
Yeah. So this is the right queue, and this is read queue. Now we have to check for suppose this is S, this is S dash, right? So we have to check condition one by one. So on the data item Q, first read operation is performed by S is initial read. That is performed by the T27 on
27, yes.
S
Yes.
in S dash also T27.
T27, yes.
Yeah. And final write.
T29, T29.
Final write T29 and here also T29. Okay. Any writes are
Right.
fair?
No.
No. So no need to check for that. So it is, now we can say this is this S is view serialized. I hope it is clear.
Yeah. So, sir, like now, if I give you this one T28, T27, T29, that is also view serializable, right?
Which one?
T28.
Yeah. No. Here you can see if we write the T28
T28,
first,
T27, yes.
T28 first. So okay, let me write first. So then you can see T27 is not performs the initial read. It will read the value written by the T28.
Oh, okay. Understood.
If this is not there, then you can say read operation.
Understood.
Yeah.
Okay.
So view serializable is clear to you. Okay. Is it clear to you, right?
Yes.
Yeah. So yeah, I think we can proceed to week 11 content.
Yeah,
Sir,
but
yeah.
we have some doubt.
Yeah, that another question like I was asking, right? Say for example, whatever we are doing this two-phase 2PL, strict 2PL or R2PL, right?
Okay.
So here all the transactions are in the same database, right? Now the thing is that I want to transfer 50 rupees from one account to another account. Okay, how this will work basically? Because transactions managers are like now two different transaction manager, right?
Yes. Mm.
So one possible way, sir, can I say something on that? Like one possible
Yeah.
thing like that I can think of,
Yes.
that let us control the transaction not at the database layer, on layer higher above that. That means when I am writing the business logic, right?
Yes.
If I say for example the Python program that we wrote, right? PsychoBG. Okay,
Yeah.
there if I start a begin transaction and end transaction, okay, and then I call two APIs, one with the database 1 and another with database 2, and then through that application program I send a commit, because that application program can see both the transaction, not the lower level transaction can see both the transaction. That is the problem.
Okay. So yeah, I'm actually I'm not aware how the bank transaction works, but one of the possible can be like suppose there is a bank A. So suppose you want to suppose you want to transfer A equal to A plus 100, and you want to subtract B equal to B minus 100. So you can lock exclusive and write a whatever, and after that this information is sent to some who manages both banks, like this is bank XYZ, and suppose this is the bank ABC, and this will it's assure that bank XYZ and bank ABC both will and both will consistency, both will work as consistency. So this will equal to plus 100, and another another one schedule will be like transaction 1. Here will be like exclusive block on B, and after that confirmation we can subtract or whatever the B equal to B minus 100. I don't unlock. I don't know whatever actually is how actually works, but this one of the possible may works.
Yeah, the
So,
problem with this is like see the diagram that you have drawn, right?
yeah.
The problem is like this communication between bank A and bank B is not at all a synchronous communication.
So
Okay.
actually I have to also see how bank actually works. So
correct. So
then,
this question, like if you can get some information, like it will be good, because I asked this question maybe like long back actually. Okay, so that time in week 3 or 4, like I asked, and there like someone told me that week 10 you will get two-phase commit. Okay,
yeah,
but
yes.
in two-phase commit also this doubt is still not clear. So if you can get me some insights like how this works in reality, because one database, that is okay. You have a transaction manager, the transaction manager is taking care of conflict serializability, view serializability, and then finally managing the transaction.
Okay, I will, if I get some input, I will put in the discourse.
Okay.
Okay.
This normally happens through payment place, right?
Hi. Yes.
So this
If you know some insight, you can give some.
the insight is it will not be like direct any time. There will be a mediatory gateway. It is mandatory in banking transaction. There has to be a gateway. Yeah. So there will be an intermediate gateway to which one bank will post their transaction. Then that transaction will be passed on to the next bank, and till the confirmation comes from the next bank, the transaction will be on hold. Okay. Then the message will come back into the original bank. Then only the commit, the transaction get completed.
Yeah. Thanks.
So that means you are saying like bank A will send a message to the gateway.
Yes.
The gateway in turn sends the message to bank B.
Yes.
And wait for the confirmation of bank B.
Yes.
Once that confirmation comes to the gateway, that gateway pass that information to bank A and then commit on bank A. And when bank B will commit?
Once that transaction is given back to the gateway, the commit will happen. Okay. Then what happens is that suppose there is a break, or there is a like the acknowledgement did not receive to the bank A, then the entire transaction will be reversed.
No, like okay, let me ask you one more time. Okay, bank A sends the message to gateway.
Yes.
Bank A didn't commit yet. Okay.
Yes, the gateway confirms that the transaction they have understood, and I'm just talking on a logical language, not on the programming language. Okay, so gateway will confirm like, yes, I have taken hold of the transaction. Okay. And the same has been passed on to the next bank. Okay, and that bank has confirmed the receipt of the message. Then that information will be given back. Okay, it is again like, suppose you are requesting a payment from say ICICI Bank, you have you have deposited a ICICI bank check into an SBI bank, suppose. So the SBI bank, suppose it is sending a message, okay, then it has to check the balance at the other end, right? The whole thing is getting managed through gateways actually. So the gateway does, there will be a balance checking message first, then there will be a transaction message, like that it goes.
So, sir, my question is like, who will commit first and who will commit second?
Each time, like commit will happen only for transaction, right? So once the message is getting received at the destination end and that acknowledgement is passed on that I have received the message, the commit happens at the original side. Okay. Once the transaction is posted at the second side, there also commit happens. Now there will be a reconciliatory process again triggered after this, basically like in between, if any communication breaks after that for confirming, then the entire transaction will get reversed. That is how you might have seen in IRCTC and all those things, the payment goes, it will get deducted from your account, then later on it comes back because the destination transaction might not have gone through.
So, sir, can I again repeat and like clarify my understanding? Like, if you can correct me.
Yeah. Yes.
Okay. Say bank app. Like, can anyone like open up a white window and start writing that? Like, at least if you can draw that, like we'll get a quick convergence.
I
Rajiv,
won't be able to do that, but you can check it up. Like plenty of documentation is available how payment gateways work.
Rajiv,
How payment gateway? Yeah, go ahead.
so first we will discuss week 11 content, then at the last we will discuss your doubt.
Yeah,
Okay,
yeah,
perfect,
that would be
perfect.
better.
Okay.
Anyway, that.
Yeah.
And actual implementations, there are strict guidelines and everybody has to follow that guidelines only. One bank cannot really implement something on their own. That is how it is.
Okay.
So Anjana, can you start?
So, how many of you have gone through week 11 content? Can you raise your hand? Or you haven't gone through it? I'm audible, right?
Yeah, Anjana.
Okay. So, looks like none of you have gone through it. No issues. So, okay. So, in week 11, we'll be studying about backup and recovery, how it is done basically. So, the first thing that comes up is what is backup, right? So a backup, say for instance, a system failure or a hardware crash happen. It will result in some data loss, right? So we will need to recover the data that was lost in the failure. So we need to keep backup of the entire database. Now, by definition, we can say that backup is basically a copy of data containing all necessary contents of a database, such as data files and control files. Okay. Now, there are two major types of backup. So the first one is physical backup, which keeps the copy of physical database like data, control files, log files, etc. Then we have logical backup, which keeps the copy of logical data from the database like tables, procedures, views, functions, and etc. Okay. Now, what is recovery? So after a hardware failure occurred, so we will have to restore the data to its latest known consistent state, right? So, in order to restore the data that was lost while the failure occurred. So that process is basically known as recovery, the restoring of the database. That is known as recovery. Okay. Now, the next question comes up is why do we need backup, right? Why backup is required? So at first, say for example, at time of a failure, say a failure occurred, or even at times when a simple human error have occurred, in order to protect our data, it's necessary to keep a backup of it. So this is the disaster recovery. Then say for instance, you are creating an app for a client, and now the client wants some changes in the app, right? So the developers might need to restore a previous version of the database, like whatever work they have done, right? Then also one more example would be, say for example, a client has sued your organization due to, say, certain false inconvenience in the project they asked for. So it's always a better practice to keep earlier snapshots of the database as a proof, right? So these are some of the reasons why backup is required. Then we'll discuss what are the types of data that can be backed up. So the first one is business data, which consists of the personal information of the clients, employees, contractors, etc., along with the details about places, things, events related to the business or the organization. Then the next type of data that can be backed up is system data, which includes disk images, then software dependency data, then log files, and then finally media files can be backed up. So media files includes photographs, videos, sounds, graphics, etc. And also they are typically much larger in size than the business data or the system data. Okay, so these are the types of data that can be backed up. So now there are a number of backup strategies. Okay, so we'll at first begin with full backup. So as the name suggests, full backup backs up everything, as the name suggests, right? So it can restore all the components of the database system as it was at the time of the crash. Also, one more thing, that it should be done at least once before any of the other type of backup. Why? Because that way we can ensure that even at times of failure, the recovery won't be too tedious. You'll understand this statement when we go through certain examples. Okay. Also, since a full backup will back up everything, right? So it will take a large amount of time in order to back up things, and then all it will also take very large amount of storage medium. So you'll understand this in a much proper way when we go through examples. Right now I'm just giving an overview. So these are some of the advantages and disadvantages. So here, if you can see, it uses largest amount of storage media per backup. Then the backup takes large amount of time among all types of backup. Yes, it backs up everything, but it also has some of its disadvantages. Okay, so which is why we have the incremental backup. So incremental backup basically backs up those files that have been changed since the last backup. It could be a full backup. The last backup could be a full backup, or it could be an incremental backup. So since it results in smaller backups, therefore the time taken is also shorter as that compared to the full backup. So therefore, however, if any of the say intermediate increment backups are lost, then recovery will not be done properly. Okay, so now let us take an example. So say an organization have 2 TB of data, and around 5% of changes have been made on a regular basis, only 5%. So in that case, if you can see here, we can have a full backup on Friday, and then on the rest of the days of the week we can have incremental backup, right? So if you can remember, incremental backup will back up only those changes that have been made since the last backup. So say here, if you can see, on Sunday we have performed an incremental backup, so it will back up the changes that have been made after Saturday. Once we perform the backup on Saturday, then whatever changes have been made on Sunday will be backed up. Okay, so now say for example, a failure occurred after Thursday, after the backup of Thursday was performed. Then what will happen? We will have to then the number of backups that will be required will be 1 full backup, then 6 incremental backups. So by doing that, we can recover, it will result in complete recovery of the data that has been lost due to the failure. Okay, so now incremental backup also has some of its demerits, which include, say, it requires more effort and time during recovery, because it will only back up the changes that have been made since the last backup, right? So it will require more effort and time. then a complete system recovery needs a full backup to start with. A full backup is required in order to start it, in order to start a complete system recovery. Then, as I said, if any of the intermediate incremental backups are lost, then the recovery cannot be 100%. Yes, it also has some of the advantages also, as it says less storage is used per backup. Okay. Then there is an in between full and incremental backup, which is differential backup. So what a differential backup backs up is, it backs up all the changes that have been made since the last full backup. Remember, last full backup. Okay. So regardless of backups that have been occurred in between. So since it does not back up everything, right? Like full backup, it does not back up everything. Therefore, it runs quicker than full backup. Okay. So let us take an example. Okay. So here a full backup is performed on Friday. Saturday, Sunday, Monday, we are performing an incremental backup. And then on Tuesday, a differential backup is performed. And Wednesday and Thursday, again, we are performing incremental backup. Okay. So now, say for example, we are backing like every day we back up our data at say 7 p.m. in 7 p.m. Okay. And say for example on Tuesday a failure occurred at say 4 p.m. A failure occurred at 4 p.m. Then can anybody tell how many backup sets would be required? Anyone? Any idea? You can say, feel free. Like.
One full backup and
yeah,
6 incremental backup.
6 incremental, are you sure? Because on
7.
Tuesday,
Yes,
4.
7.
no, it will be okay. Someone said 4.
Yeah, Saturday,
Will
Sunday,
it?
Monday.
Yes, that would be correct. 4 backups would be performed. 1 would be full backup and 3 will be incremental backup. Okay. So it's Rajiv, right? Okay. So why wasn't it 4 backups, like like 5 backups, full backup, incremental backup, incremental backup, incremental backup, and differential backup? Can you say?
Because Tuesday it failed at 4 p.m., right?
Yes. So
So
we
you
are
have not.
performing backup at 7 p.m. Yes, you're right. So since we are performing backup, every day at 7 p.m. and the failure occurred at 4 p.m. So by that we can understand that on Tuesday, the backup was not yet done, right? So the data that got lost was from Friday, Saturday, Sunday, and Monday, right? So that is why we will need 4 backup sets. That is 1 full backup and 3 incremental backups. So anybody any doubt in this particular example? I can discuss it again.
Here you said 7 p.m. is the normal backup time, right?
Yes.
So previous day 7 p.m. any of the backup might have happened.
Backup, incremental backup happened on Monday.
Increment any, I'm just telling, any every day 7 p.m. one backup happens. It can be full, it can be incremental, it can be differential.
Yeah, here we are specifying it, right? If you can see.
So now between that 7 p.m. to 4 p.m. So what happens to that data?
Like if a failure occurs at 4 p.m.
Yes.
So we are performing a backup on 7 p.m. every day, right?
Yeah, 7 p.m. every day. From 7 p.m. to 4 p.m. there will be something. No? So those data is lost already.
Yeah, that data will be lost because we haven't performed any backup, right?
That will be
on
lost,
that,
right?
That data will be lost because we haven't done any backup. So how can we recover it, right?
Yeah, that's why there is a thing called recovery point, right? Like.
Yeah, please go ahead.
Yeah, there is one terminology called RPO, like recovery point objective. So you need to set that, like how much backup, how much data loss you can tolerate. That depends upon the business. So 7 p.m. after 7 p.m. Monday to 4 p.m. Tuesday, you lost that backup. So you have kind of roughly around 8 hours or something there, 8 hours or 12 hours, that is the RPO. Like you can lose that much
Data.
amount of data.
Yeah, that's right. Okay, that's clear, right? Any doubts in this particular example? Anyone?
Ma'am, if system is failure in 8 p.m., then
At 8 p.m. on Tuesday, right?
yes, ma'am.
Yes, then there will be five backup sets, because here the differential, no, actually it will be only two backup sets. So since differential backup has been performed, right? After that the failure occurred. As I said that at 7 p.m. we perform a backup every single day, right? So on
Yes.
Tuesday a failure occurred at 8 p.m. Yeah, right? You mean that only, right?
Yes, ma'am.
So we have performed the differential backup, and after that at 8 p.m. the failure occurred. So now the backup sets that we will require is one full backup and one differential backup, because differential backup will backup all the changes that have been made since the last full backup, right? If you can remember by the definition. So the differential backup will backup all the changes made on Saturday, Sunday, and Monday and Tuesday itself. So in total, two backup sets will be required. So is that clear to you?
Yes, ma'am. Thank you.
Okay, so we'd head to another example. Okay, yeah. So here we are using all the three backup strategies. So what we are doing out here is, so at first a full backup has been performed. So the full backup consists of the change that is A. Then the next day an incremental backup has been performed. So since incremental backup will backup only the changes that have been made since the last backup, so these are the changes that have been made. So this will be BCD will be backed up. Then a differential backup is done. So what a differential backup will do is it will back up all the changes that have been made since the last full backup. So this is the last full backup. So it will back up B, C, D and F. Okay. Then again, next day an incremental backup has been performed. So it will back up only the changes that have been made since the last backup. So these are the changes that have been made. So D, E. Then again, finally, a full backup has been performed. So full backup will back up everything from the last full backup. So it will be A, B, C, D, E, F, G. So
Now, if you say like a differential backup takes backup of all the changes from the last
full backup.
full backup,
Right.
then once a differential backup is taken, then the intermediate incremental backup is not required then, no?
No, not required. Say a failure occurred here after this backup has been performed. Then we'll only need full backup and a differential backup, right? This incremental backup won't be required, because ultimately this
Yeah,
differential backup.
we would be needing incremental backup after that differential backup only. Up to the differential backup, it is not required, no?
We'll need incremental backup after differential. I didn't.
No,
got this.
if you go back to that previous question you had, like Monday,
This one.
Yeah.
Yeah.
You just see Tuesday. Okay. Tuesday, it was supposed to be differential backup. That did not happen that day.
Since a failure occurred at 4 p.m.
Okay. So suppose if it was Wednesday, then Tuesday differential backup plus one incremental backup would have done.
Look, if a failure occurred on Wednesday after this after this backup has been performed, right? You are asking that only what will be the backup sets?
Yes. Suppose in Wednesday after that incremental happened.
Yeah.
After 7 p.m. then we need to take the full backup, then the differential backup plus the incremental backup.
Yes, that's right.
If it is before, full plus differential, that's it.
Yes, that's it. Yes,
okay.
You're right.
Okay. Thank you, sir.
Okay. So we'll take a much bigger example out here. So, okay, let me zoom in. Okay. So here we are performing monthly data backup schedule. Okay. So what we are saying, this is the Jan month. This is the January month. Okay. And what we are doing is on the very first Sunday, we are performing a full backup. And then on the rest of the Sundays, we are performing differential backup. And then on the rest days, we are performing incremental backup. Okay. So now, say for example, I'd want to ask all of you, say for example, a failure has occurred on 21st, on 21st, like after the backup has been done, after that a failure occurred. So would anybody like to tell how many backup sets would be required? After 21st, like after the backup of the changes made on 21st are done, after that a failure occurred. So what will be the number of backup sets?
8.
Okay, can you tell how?
Now the first full backup Sunday,
Right,
then 15 differential backup,
exactly.
2, then 16th, 17th, 18th, 19th, 20th, 21.
Yes, that's right. So one full backup will be required, one differential backup will be required, and 6 incremental backups will be required. So in total, 8 backup sets will be required. Okay, so now I'd like to ask, say for example, we are performing a backup again at 7 p.m. Okay, and on the first fab, failure occurred at 12 a.m. A failure occurred at 12 a.m. So can anybody tell the number of backup sets?
7.
7.
Sorry. 1, 2, 3, 4, 5. 5.
How come?
That means first full backup,
Yes,
29th differential backup,
correct.
2, then 30, 31 first.
First at 12 a.m. the
Okay.
failure occurred.
Then up to 31st.
Yeah. So in total, the
1, 2,
backup
3,
set,
4.
yes, one full backup, one differential backup, and 2 incremental backups. Yeah. So anybody, any doubt in this particular example? Please feel free. Anyone?
Ma'am, how it 1 plus 1 plus 6, how it will come?
Okay. So we assume that on 21st, after say on 21st at 8 p.m. a failure occurred. Okay. So now we
After
need to
it,
back up. Now we need to get a complete recovery of the data that was lost, right? So
yes.
here at first we have a full backup, right? So we'll consider one full backup. Then if you can see that second, third, fourth, fifth, sixth, and till Saturday we are having an incremental backup, right? And then on the 8th we are having a differential backup. So what a differential backup does, it backs up all the changes that have been made since the last full backup, right? So it will back up all the changes that have been made from 2nd to 8th itself, right? Okay.
Yes.
So after that, from 9th to 14th, again, incremental backup was done. After that, on 15th, a differential backup was done. So again, from the definition, all the changes made since the last full backup will be recovered, right? So it will back up all the changes that have been made since from 2nd to 15th itself, right? So
Yes.
after that, we have from 16th to 21, again, incremental backup was performed. So by that, we can say that one full backup will be required. Okay. Then one differential backup would be required for backing up all the changes that were made from 2nd to 15th. And then 6 incremental backups will be required. So that is how we get 6. So finally, we got 8. Is it clear?
Yes, ma'am.
Okay. So anybody, any doubt? Okay, so instead of differential backup, you might think that we could have taken incremental backups, right? For the entire month. But then the total number of backup sets for the complete system recovery would be 31 backup sets. It would be too tedious, right? So that is how it shows that differential backup can improve efficiency of recovery when planned properly. Okay, so now I'd like to take an example. Okay, so I'd like all of you to volunteer. So here, what is happening is a backup schedule has been given for a week. Okay, so on Monday, Tuesday, incremental backup is performed. Then we are assuming that on Wednesday, again an incremental backup is performed. Then Thursday, Friday, again incremental backup. On Saturday, we are performing a full backup, and on Sunday, we are performing incremental backup. So in this scenario, how many backup sets have to be loaded for a complete recovery if the system failure occurs on Friday after Friday's backup is completed? So on Friday, after the backup has been completed, what will be the total number of backup sets required? So here a failure occurred. Okay. So anyone? How many backup sets will be
2, 3,
required?
4, 5, 6.
Are you sure? Would you like
Five.
to set?
Because like you have never given the full backup, so that means there is a full backup somewhere
No.
before
Okay.
Monday.
Okay. Let me show it to you in this manner. Say, for example, it is going on. Okay. So say after Sunday, again, Monday, Tuesday, Wednesday, we are performing in this manner only. Don't only consider this much. Okay. So, it like here also
Okay,
there are,
okay.
yeah.
Understood. It is the schedule for the entire month actually.
Yeah, right. That's right. We have
Then
just taken for a
1,
single week.
4, 5, 6, 7. Then 7.
Okay, how? Can you tell?
First the full backup, Saturday's backup.
Yes.
Then Sunday, Monday, Tuesday, Wednesday, Thursday, Friday.
Yes, that's right. So in total, 7 backup sets will be required. So anybody, any doubt? Why it is 7 or anything?
Yes, ma'am. Please repeat.
Okay. So what the question asks here is, a failure has occurred after the on Friday, after the backup of Friday has been completed, right? So here, consider this is a single week's this is a week's backup schedule, and this is happening for the entire month. The same schedule is happening for the entire month. Okay, so obviously there are more weeks in prior and after also. So this is the like order in which the backup schedule is performed basically, right? So on Friday a failure occurred, right? So the Saturday, Sunday. So here on Saturday we have a full backup. On Sunday we have an incremental backup. Okay. So we will get one full backup. Then Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday. So one full backup and 6 incremental backups. So that is how we will get 7 backup sets. Is it clear?
Ma'am, system is failure in after Friday. Then why we are considering Saturday and Sunday?
As I said, that this is the like we are simply like if you can remember from the last example, it was the backup schedule for the entire month, right? So here from that entire month we are simply considering a week. We have not written down the other like weeks, but the entire month will follow the entire all the 4 weeks will follow this particular order only of backups.
So
So
these
see,
are actually previous Saturday, Sunday.
yes, that's right. Suppose, say for example, this is 28th. Okay, so 21st and 22nd. Okay, sorry, yeah. So the backup will be done from 19th. So the backup will be done from 14th and then 15, 16, 17, 18, 19, and then on the 28th. So are you getting the point? Am I audible?
Yes, yes.
So did you got the point? Um, please tell if it's clear to you or not.
No, ma'am.
It's still not clear. Okay, it's still not clear. Okay, so you remember this particular example, right? So
Yes, ma'am.
in this case, say for example, from 15th to 21st, we are considering on 15th we have differential backup, and on the other days we are having incremental backup, right? So in this particular example, consider like this is 15th and this is 21st. I'll okay. So consider this is 15th and this is 21st. Okay. So if you can remember, what we did out here was we performed differential backup, right? So say we haven't okay, so we performed the differential backup, so we took the backup from 2nd to 15th itself, right? Not just the week itself, but the previous weeks also. We are
Yes.
taking backup from the previous weeks also, right?
Yes.
So in that similar way, we have from 1st to 15th, we will be performing the same order of backup schedule. Like on Monday, like in the previous example, we were performing on the first Sunday, we were performing full backup, and on the other Sundays, we were performing differential backup, right? And on the rest of the days, we were performing incremental backup. However, here we are performing a full backup only on Saturdays. All Saturdays we are performing a full backup, and on the other days we are only performing incremental backup. Okay, so
Yeah.
so since a failure occurred on Friday, so what will happen, all the data that was there from 1st to 15th will be lost, right? Because a failure occurred. So what we will have to do is we will have to recover all the data from 1st to 1st to here, from 1st to 19th, right? Because on 19th a failure occurred. So what we will do is, so since on Saturday a full backup occurs, every Saturday a full backup occurs, and then on the rest of the days incremental backup happens, right? So this is 13th, this is 14th. Okay, so what we will do is we will take the last full backup and then the remaining incremental backups, because this full backup will back up all the changes that have been made from 1st to the 13th, right?
Yeah. Got it, ma'am. Got it.
Yeah. Okay. Okay. Anyone, any doubt? Okay. So we can head to the next example. Okay. This is a similar example, just that here on Wednesday, we are considering a differential backup is done. And we need to see that in this scenario, how many backup sets have to be loaded for a complete recovery if the system failure occurs after Friday's backup is completed. Again, here, a failure occurred. Okay. And that the given Saturday is on 28th November and Friday is on 26th November. So this Friday is 26th.
4.
26. Sorry?
4 backup.
Okay, 4 backup you're saying. Okay, just a minute. So I'm making it easier for you to understand, nothing else. So this will be 28th. So full and incremental. Okay, so you said 4 backup, right?
Yeah, the
So,
full differential incremental.
yes, that's right. So this full backup that was done on 28th, then the differential backup that was done on
Wednesday.
24th, yeah, on
Yeah.
Wednesday, and then the 2 remaining incremental
Two,
backups. So
yes.
total would be 4 backup
4.
sets. Okay. So anybody, any doubt in this particular example or in any of the backup strategies? Anyone? Okay. So, okay, then we can move to the log-based recovery. So, what is a log at first? So, a log is nothing but a sequence of records which maintains information about update activities on the database. Update activities on the database. It is kept on stable storage. So, does anybody of you know what is a stable storage? Like what happens in stable storage?
No.
Okay. So what happens is there are three types of storage medium: volatile, non-volatile, and stable storage. So volatile, when we are keeping data in a volatile storage,
It's a
then
stable storage. Stable.
yeah, as the
Okay.
name suggests.
Okay. I heard it wrong. Table. I heard table storage.
Okay, no.
Okay.
So what happens is in volatile, if we keep data in volatile storage, at
Mhm.
times of system crash or hardware failure, all the data will be lost and we
Lost.
won't be
Yes.
able to recover it. Then
Mm.
in non-volatile, the data can still be lost. Like it won't be affected from system crash, but however, from some natural disasters, say fire, flooding, something happens, then
Mhm.
data that is stored in the non-volatile storage can also be lost. However, what happens in stable storage is it can survive through all the types of crashes. Now you can say how that happens. So in stable storage, what happens? Multiple copies of the data have been kept in separate disks. Also, like these multiple copies have been kept in remote places, so that, say for example, in a single place, in a certain place, some natural disaster occurred, then that same copy would be present in a remote place also, right? So no data would be lost. So that is what is stable storage. So stable storage does not result in loss of any data if we store data in stable storage.
But it
Okay.
is still in magnetic disk, right? Magnetic disk or tape.
Yeah.
Okay.
Yeah. So these activities on the database are kept on stable storage, and when a transaction enters the system and starts execution, it writes a log about it. So if you can see, when a okay, so when a transaction TI starts, then TI start has been written to the log. However, when a transaction TI finishes, the log record TI commit is written as the last statement. Okay. So here, if you can see that when we need to like update a particular update the value of a particular, say X or Y or anything, then what we will do here, we will take V1, which is the V1 is the old value and V2 is the new value. So what will happen is the value of X will be converted from V1 to V2 because V2 is the new value. We'll understand this. So now we will go through some modification schemes, which are, so the first one is immediate modification. So as the name suggests, all the uncommitted transactions are allowed to be updated or written on to the buffer or disk before the transaction commits. That is, in other words, we can say that database is immediately modified or updated after every operation. That is why the name is immediate modification. Even before the transaction commits, all the operations, all the changes or all the modifications that have been done are directly updated on the database. So yeah, the order in which blocks are output can be different from the order in which they are written. Okay, so remember that. Then the another type of modification scheme is deferred modification scheme. So here all the updates and changes are made on the buffer or disk at the time after the transaction, after the like at the time of the transaction commits. So once the transaction commits, the changes that have been made will be like updated on the buffer or the disk. So that is the difference between immediate and deferred modification. So here we will be covering immediate modification scheme. So let us take an example. So here, if you can recall that when a particular transaction starts, so this is the log that is written. So T naught is the transaction and we start this particular transaction. Then we have A. So consider this as V1 and V2. So V1 was the old value and V2 was the new value. So here in T naught, the value of A is updated from 1000 to 950. Then again in T naught, the value of B is updated from 2000 to 250. Here as you can see. So it is written in the buffer even before the commit operation happened, right? Because this is the immediate database modification. Then another transaction started. So the value of C was updated from 700 to 600. It was written in the buffer and then a commit operation was performed. And also remember the point that said the order in which blocks are output can be different from the order in which they are written. So the order can be different. You don't need to worry about it. So this is immediate database modification. We'll try to understand with the help of some examples also. Don't need to worry about it.
So, ma'am,
So,
in this
yeah.
example,
Mhm.
yeah, these whenever you are saying write, and that you are saying writing in the buffer, right?
Right,
So
right.
that is still in the volatile memory.
Yes.
Okay.
So yeah, so when we perform commit, it will go to the disk. It will get output to the stable storage.
Okay.
Yeah. So then we also perform some undo and redo operations. Okay. So when we perform an undo operation on a log record, it writes the old value to X. That is, it will write the old value V1 to X. Then when we perform a redo of a redo operation of a log record, the new value, that is V2, will be written to the to X. Remember this thing. This will be helpful in the further examples that we will be discussing. So what happens in undo when we perform undo operation is it restores the value of all the data items updated by TI to their old values. Okay. And in redo, it sets the value of all data items updated by TI to the new values. So remember this. Okay. So after this, yeah, you can go through all this. Okay. So here, what is compensation log records? Okay. So say for example, we have T1 start. Okay. And then we have T1 X, then say V1 and V2. Okay. And then say a failure occurred. Okay. In that case, what will happen is, if you can see out here, so we'll have to scan log backwards from the end. Okay. That is rollback, transaction rollback. So what will happen? We will perform undo by writing V1 to XJ. So this is V1 and we'll have to write V1 to X. So what will happen is T1 X and V1. So we will, since we are performing undo, so then we will write the record as you can see. So when we see that there are three values only used, it means that an undo operation is performed. So which means that this log record is basically known as compensation log record. And since we are scanning log backwards from the end, right? So once the record TI start is found, so since we are going this way, so this has been changed. Now we have reached TI start, right? So then write the log record TI abort. So it will be T1 abort. You can just go through it. It's nothing that important. Just what is compensation log record, okay? Then, okay, yeah, this is important. So a transaction TI needs to be undone. When do we need to perform undo and redo operations? So when a particular log contains the record TI start, okay? So say T1 start has been performed, okay? And then certain modification and updates have been performed. And then a failure occurred. And then a failure occurred and no TI commit or TI abort was performed. This record was not there. Then we can say that we need to perform an undo operation when TI commit or TI abort is not performed. Remember, that is when we will perform the undo operation. Okay. However, when do we need to perform redo operation? So when say TI start, this particular record has been the log contains this record, then certain modifications have been done, then it consists of T1 commit. Okay. And then after commit, a failure occurred. So failure occurred. So in that case, we'll have to perform the redo operation. So that is when a redo operation will be performed. So please remember when undo and when redo operation needs to be performed. We'll understand this with the help of some example. Okay, yeah, here. So say for example, these are 3 examples. Okay, we'll go one by one. So here we have a transaction T0. So it started, and then the value of A has been updated from 1000 to 950. The value of B has been updated from 2000 to 2050, and then a failure occurred. Okay, so what will happen is, since the TI commit or T0 commit was not performed, so we will have to undo all the changes that have been done. So what will happen? What happens when we perform undo operation? Will change the will update the value of A and B to the old values. In redo, we update it to the newer values, and in undo, we update it to the old values. So the value of A will be set to 1000, and the value of B will be set to 2000. If you can see, B is restored to 2000, A is restored to 1000, and log records T0 B 2000 are written out. Okay. So okay, let us get into this particular example. So here T0 start happened, then the values of A and B got updated, then it committed. Okay, and then another transaction started, the value of C got updated. However, right at that point, right after that step, a failure occurred. T1 did not commit. So we'll go step by step. So since T0 started and committed, so and after that a failure occurred, so we can say that T0 needs to be redone. And T1, so T1 have not committed, right? And the failure occurred. So we can say that T1 needs to be undone. So when we redo, the value, the newer values get allotted. So the value of A will be 950, the value of B will be set to 2050. Then since T1 needs to be undone, so the value of C will be set to 700. Okay, so now let us take this example. So T0 start happened, and then the value of A, B got updated, and then it committed. Then T1 started, the value of C got updated, and then it committed. And then a failure occurred. Okay. So then what happens? Both T0 and T1 are performing the commit operation, right? So T1
Redo.
also, yeah, T1 also needs to be redone. So the value of A and B will be set to 950 and 2050, and the value of C will be set to 600. So that is how we perform immediate modification database. Then all these redoing and undoing of transactions in the log can be very slow. Say for example, a failure occurs even after we have performed the complete recovery. So we have to redo, undo the transactions again and again, right? So in that case, we can use checkpoint. So when a checkpoint occurs, we can ensure that the transactions have been committed. The data for those transactions have been reflected on the secondary storage. So please remember that scan backwards from end of log to find the most recent checkpoint record. Only transactions that are in L, which is the checkpoint, or started after checkpoint needs to be redone or undone. The transactions that committed or aborted before the checkpoint happened can are already updated output to the stable storage. So say for example, and just so say here a system failure occurred. Okay, and then there are two checkpoints, say L1 and L2. So what we need to do, and then there are certain transactions, these I'm considering as transactions. Okay, so say certain transactions are there. So what we need to consider is we need to scan, as you can see in this particular statement, we need to scan from backwards, from end of log record to find the most recent checkpoint. So L2 is the most recent checkpoint. It is the most it is performed before the failure, right? So it is the most recent checkpoint. So only then the second point states that only transactions that are in L, that is the transaction that are running while the checkpoint happened. That is, if you can see, this particular transaction was running when the checkpoint happened, and the transaction that started after the checkpoint. So if you can see, this and this particular transaction started after this checkpoint, right, needs to be redone or undone. Then transactions that committed or aborted before the checkpoint. So if you can see, this particular transaction committed before the checkpoint occurred. So we can simply ignore it because all the updates have been made to the stable storage. Okay. So yes, from this example, okay. So here we have only one checkpoint, right? So T1 is being committed before the checkpoint occurred, right? So we can simply ignore it because all the updates have been like put to the disk. Now T2 is running while the checkpoint happened. So T2 needs to be redone. T3 started after the checkpoint and committed before the failure occurred. So T2 and T3 needs to be redone. Then T4 was running at the time of failure. Remember, at the time of failure, so T4 needs to be undone. You can connect these with the previous examples that we did from the log-based recovery or the immediate database modification, where a failure occurred and then like a failure occurred before the commit was performed. So what we used to do, we used to undo it. However, if a commit is performed before the failure, we will redo it, right? So in that case, here checkpoints also works. So let us take some examples.
So, ma'am,
Yeah.
one question: this commit is an atomic operation or what?
Atomic operation, by that what you mean?
See, commit, like say for example, you have 10 items, you change 10 items, okay, and those all these things are in the buffer, right? Now you are issuing a commit command. Is commit a atomic operation?
I'm not able to understand actually.
Hello?
Yeah.
Okay.
Am I audible?
Yes, yes.
So what you're saying is, say we have A, B, C, D, and all the values are
In
updated
buffer. In
in
buffer,
the
yes.
yeah, in the buffer.
Now you issue a commit operation.
Okay. Say we have this T naught, and in this, so we started it, and now you say that we have committed it.
Hmm.
Yeah.
So
Then
is commit atomic?
like the values of A, B, C, D will be updated to the stable storage, right?
No, no. That of course. Like if the commit works successfully, then your ABCD will be updated.
Yes,
My
that's
question
right.
is, if this commit is not atomic, and before that a context switch happen in the operating system and the system fails. So you will be essentially writing commit in the log file, but actually the commit didn't work. Because log file you are keeping it outside the transaction manager itself, right?
Okay.
So that is the question. That is why the question is.
Rajiv, hello?
Yes.
Yeah, the commit can be atomic also and non-atomic also. Means whatever the changes in the database should be right into the stable storage. So it can be atomic or it
So
can be,
if okay, now if say for example commit is not atomic, okay,
yeah.
in the log file what you are writing, T0 commit, right?
Yes, yeah, T0 commit.
Okay, and you are doing a commit.
Yeah, yeah.
Now commit fails. You have already written in the file
Yeah,
T0 commit.
then see, after the successful of commit, if there are two conditions, it's successful commit or it will not have successful, right? So if successful, then it's good. Otherwise, we can physical, we have log record, so we can.
No, that's the point. Is say for example you start T0 start,
Yeah,
then you updated A, B, C, D. Okay.
yeah.
All these
Okay.
things you have written in the log file as well.
Yeah, yeah.
Now you are issuing a T0 commit.
Yeah,
Okay.
T0. Yeah.
Okay, perfect. The T0 commit you also wrote in the log file.
Okay.
Now your commit is running. Now
Yeah,
commit
yeah.
fails. System crashes because
So,
commit is not an atomic operation. System fails. Okay. Now
so
in these
see,
circumstances, what happens? Both these log files and your commit, they are in inconsistent mode.
so see, if it is success, it can be success or it can be fail, right? So if it is success, then it's fine. If it is not success, then we have log records. We can.
But before that, you have already written in that log file, right? T0
So
commit.
a T0 commits. See, after the T0 commit, if it's success, then it is fine. It can be. Uh, it
No,
can be.
if say for example the T0 commit statement is not there in the log file.
Okay.
Okay, what you will be doing? Will be
See,
undo.
suppose, yeah, we
You will
will
undo
be.
the stuff, right?
Yeah, we will
If
be.
T0 commit is there, you will be doing a redo. Okay.
Yes.
Okay. Now T0 commit is there. T0 commit is there, but actually it has not happened.
Then we can undo the operation.
But if T0 commit is there, you will do redo.
So see, if it is successful, then we can redo.
No, but the success and failure you are saying only with the T0 commit, right?
Yeah.
But the thing is that if commit is not an atomic operation, in that circumstance, you never know that when you have written the commit and when commit has actually finished. So both are not synchronized. That's the point.
So yeah, so that's why we are means maximum times we use atomic commit. Maximum in database, maximum we use atomic commit.
No, but if commit is not atomic, then it is a like in my mind, like you issued a commit and the commit doesn't work. So that will be detrimental actually. So that's what the point is. Like, is there a possibility that like is there incident like commit is really not atomic?
We'll get back to you after the.
Okay.
Yeah, Rajiv, we'll get back to you on that. Okay. Okay, so we'll understand this. Okay, with the help of some examples. Okay. So here, consider a log of transaction as shown where the immediate database modification scheme is used. So suppose a transaction failed before step 5. So before step 5 here, a transaction failure occurred. So here, if you can see that we have a transaction T0, so it started and it updated the values of A, B, and C. And then right after the step 4, a failure occurred. So by that you can say that the commit operation was not performed for T0. So now you need to tell which among these options will be correct. So at first you need to tell me whether what operation will T0 be performing. Undo operation?
Undo.
Why?
Because commit is not there, right?
Yes. So since commit is not there, so T0 needs to be undone. Now can you tell me the value of A, B, and C?
Yeah, A 1200, B 1000. Sorry, A 900. Sorry, A 12, 1200. Yeah, because that is the old value, right?
Yeah.
B 1000 and C 800.
Yes. So in undo, when we have an undo operation, what we do is we will update the value of A, B, and C with the old values. So these are the old values and these are the new values. So when we perform redo operation, we'll update the value of A, B, C with the new values. Remember that. So by that we can say that this is the correct answer. So T0 needs to be undone and the value of A will be 1200, B will be 1000, C will be 800. So anyone, any doubt in this question? Okay, then we'll head to the next question. So again, an immediate database modification scheme is used. So a failure occurred after the step 12. So now please tell what operations will be done for T1, T0, T1 and T2. Please check the, yeah.
Yeah, T2 undo and remaining all redo.
Remaining all will be?
Remaining all will be redo.
Okay.
T2
So
will be undo.
please check here. We have a checkpoint also.
Okay. Checkpoint. So that means
Yeah.
T1 E400. That will be T1 E400. That will be there.
Okay. Okay, you can go line by line. So tell me which operation will be performed or any operation will be or will not be performed on T0.
Okay, T0, right? T0
Yeah.
no operation.
So since T0 started and it performed the modifications and then it committed before the checkpoint and before the failure. So by that, if we can remember that the transactions which committed or aborted before the checkpoint happened. So those can be ignored. So by that we can say that T naught needs no action. Okay. Then can you tell for T1? So yeah. Anyone?
T1 start, T1
Hmm.
commit. T1 will be redo
Okay, why?
because T1 started at 4 and
Yes.
then in 11, right?
And committed at 12.
12
Yeah.
committed. Checkpoint is at 10.
Yes.
So that means you need to redo the entire thing.
Yeah, because the transactions which are in the checkpoint or which runs when checkpoint happen needs to be redone, right? So T2, T1 needs to be redone. Then T2,
It is rollback.
okay, T2 needs to be, so roll back.
Yeah, because T2 doesn't have a commit.
Yeah, so by that you mean that T2 needs to be undone.
Undone, yes.
Yeah, so T2 started before checkpoint. It was running through the checkpoint. It has also not committed when the failure occurred. So T2 will be undone. So by that we can say transaction T1 needs no recovery. Is that true? No, it needs a recovery because it needs to be redone. Then transaction T2 needs to be undone. Is it true? Yes. Then transaction T0 and T1 needs no recovery. So it's not right? Because T0 needs no recovery. However, T1 needs redo. Then transaction T1 needs to be redone. So yes, this is the correct option. So anyone, any doubt in this particular question? Okay, so we'll head to the next example. So again, it is quite similar. So a crash occurs after 14th step. So please tell what happens. So T0, T1, T2. Okay, so here please look carefully. We have two checkpoints. Okay, so what happens in that case? So go line by line. What will happen for T0?
T0, where it is committing 6. T2, T0 is redo.
Are you sure? T0
Yes,
has,
yes.
No action.
sorry?
Yeah.
No action.
Yeah.
No. T0, nothing. Because
Yes.
checkpoint is at 13th also.
Yes. At 13, you need to consider the checkpoint, which is the
Correct.
from the backward, you need to check the most recent one, right?
Most recent, yes.
So you
T0
don't
nothing.
need to consider this checkpoint.
Yeah, no
Only
action.
consider checkpoint L1, right? So T0 needs no action. Okay.
T1 also no action.
So T1 started and
12th,
okay,
T1
it's
commit.
committed. Yes,
Yeah,
before
no
this
action.
checkpoint. So it
Yeah.
also needs no action.
Yeah, T2 undone.
T2 undone because T2 started and it did not
End.
commit before the failure. So it needs to be undone. So by that we can say that this is the correct option. Okay, anybody, any doubt? Anyone? Okay, we'll head to the next example. So here there are three transactions, T1, T2 and T3. So can you tell what will happen after the crash occurs? Which among these options will be correct?
End of log crash. Log crash means that is at the last line, right?
Yes, after all these have happened, after that a crash happened.
So T1 start, T1 commit, where it is T1 commit. T1 commit, checkpoint. So T1 no action.
Okay, T1 will be no action.
Action. T2 start. T2 is redo.
T2 is redo because it started and committed after the checkpoint.
Checkpoint, yeah. T3 undone.
T3 undone because it was running when the crash happened, right? So by that, so T1 is committed before the checkpoint, it will be ignored. So this is the correct option. Then T2 is committed, but after the checkpoint, so it will be ignored. So it is not correct. T3 did not commit, so redo. That's also not correct. Means it did not correct, so it needs to be undone. Then T2 is committed, but after the checkpoint. So redo all its updates.
Hmm.
So yeah. And any doubt in this particular question, anyone? Okay, so we'll move to the last example. So here, please choose the options which are right. So what will happen?
Yeah, the T4 is your read. T4 is redo.
Okay, T4 is redo.
T5 redo. T6 undo.
T5 is also redo, and T6 is
Undo.
undo. Okay, what will happen for T1, T2, and T3?
Not like no action.
No action. Why? They are going through the
Checkpoint
checkpoint.
2.
Okay, so checkpoint 2 is what we consider, right?
Hmm.
So by that we can say T1, T2, and T3 can be ignored,
Ignored.
and T4 and T5 needs to be redone,
Redo. Yeah.
and T4 and T6 needs to be undone. That is not true, right? Because T5 needs to be redone, not undone.
Correct. Correct.
Yeah, so these are the two correct options. So anyone, any doubt, or is it clear the checkpoints? No.
What is happening in T4, ma'am?
For T4, if you can see that it is running when the checkpoint happened, right? So the transactions which are in the checkpoint and start and commit after the checkpoint, they need to be redone. So if you can see, T1 was running when the checkpoint occurred, and T5 started after the checkpoint. So by that we can say that T4 and T5 needs to be redone. T6, if T6 would have committed before the system failure, then T6 would also have been redone. However, T6 was running when the system failure occurred, right? So that is why T6 needs to be undone. So is it clear?
Yes.
So anybody, any doubt? Okay, if anybody have any doubt, then you can ask, or else I guess we can wind up the session.
Okay, ma'am. One question.
Yeah.
So, for example, when you take the backup of the database, right? So that time, like, does this database automatically locks itself, or it still allow the transaction?
When you take the updates.
Yeah, you are taking a backup, okay. So that time, does the database lock itself automatically, or still it allow transaction?
It will.
Rajiv,
Yeah.
there are two types of backup: hot backup and cold backup. Cold backup. In hot backup, while transaction means while database is running, we can take backup. But in the cold backup, database one is not running. So in hot backup, I think we can begin the transaction.
No, I think the hot backup and cold backup, like whatever I studied, like it is little bit different. Hot backup is you do not shut down the database instance. Okay, like while the database is running, you can take the backup, but this doesn't like tell anything like when you take the backup whether it will allow the transaction or not. In cold backup, what you do basically, you shut down the instance. That means no one can access the database at all.
Yes.
Correct. So
yes.
during hot backup, that means your database is running.
Yes.
But does it allow any transaction?
I think I think it is allowed, but I'll get back to you in the next session in detail. It is allowed or not in hot backup.
Okay, because the reason is like the problem comes if it allow transaction.
No, but that normally happens in a way like, no, suppose you are triggering a backup, and that particular timestamp will be taken, and the database will be kind of, it is not like what we imagine when we are writing into a tape. If it is taking some 15 minutes or 20 minutes or 1 hour, the entire backup database will be kept idle, or it is not that way. It is something like at that particular when that particular time the backup is triggered, that time the data will be dumped to a backup file, and that backup file will get written into the backup media. Okay, so there will be only a momentary pause in that time, and that particular moment the transaction will not be allowed.
See, not sure like if I understand correctly, because when you say momentarily, what does that mean essentially?
It will be like that backup. There will be a backup file which is getting created prior to writing the backup actually. Okay, so there will be two steps. Okay, so creating that backup file is it doesn't take time. So suppose we are taking a time like we are triggering at 7 o'clock. That particular moment, the backup file will be created as a dump, and the transaction will go on from there onwards. But the backup writing will happen from that dump to that media.
No, but if you see like when you take a like say for example 1 terabyte database backup, okay, and if you write that command like export into a dump, okay, you see that dump file is kept on increasing. That means it is reading and writing that into the dump file. So the dump file is continuously getting modified till the time your backup is
That
completed.
normally, as I understand, it get managed between the memory, then hard disk, then the backup media. That way it is.
No, that is okay, but my point was different. Like you issued a expdp command, okay, export dump command. Now you started this backup. You are taking the data at the same time. You are allowing the transaction.
It will be the
It will be
transaction
corrupted
will be
actually.
allowed, but there will be a timestamp for everything. No, so that particular transaction, when it has taken place, that last transaction time will be taken as the backup initiated time. Then it solves the problem. No?
Not sure if it works in that way. Like I'm not
Every
sure actually.
every data will get time stamped, right?
Every data get timestamp when you do a transaction. This export dp is not doing any transaction. Who will use the timestamp actually? It is not a transaction, right?
No, the transactions happens in the database, right? So your concern was the transactions happening in the database will get stopped or it will get continued. That was your concern, right?
Yes, yes.
So the transactions which is happening, the moment it is time stamped, that concern goes away, because from we always will have prior to that timestamp and after that timestamp, we always can take.
No, but the time you write that expdp command, right? It doesn't give a timestamp to the database that I am taking that database at this timestamp. It doesn't give that kind of information to the time database. That is the reason I asked that question.
It need not, no, because always there is a system time which is driving all this from behind. No, so the moment you are initiating a command, the system knows what time it is.
Okay, sir. Like if you can get some more details and like that will be helpful. Another question is like another concept is there like taking the snapshot. Okay, how that is different than this backup?
And I'm not sure about that. Snapshot thing. Snapshot is basically between the like every time creating a mirror of what is happening. That is what is actually called snapshots. I do not know.
No, like I'm asking to the like.
Okay.
PODs.
Yeah, we'll get back to the next session in both questions.
Yeah, Rajiv. So a snapshot, you can think about whatever you changes in the operating system or something. So that will saved in that, means whatever the changes or the settings you have prior done, right? So that is snapshot, right? Hello.
Yeah, say for example, like when you take a snapshot, say for example, you are taking a backup of a 1 TB database. Okay, like
Yeah.
when you take this database backup, right? It will take
Yeah.
more than half an hour time.
Yeah.
Okay, and when you take a snapshot, it takes like a few minutes.
So
So what
exactly, I
happens in
have.
that snapshot? Yeah.
Yeah. So before moving to that, what Anwar said, that the whatever's in the backup you said. So first, you do not know about the what is the internal mechanism of the one DBMS, means database system management. So database management system, it has internally log also, it maintains log also. So different mechanism also they maintains. A log also maintains a log. And so first time when you trigger any backup, means, right, so you want to particularly backup from here to, suppose this is the 8 p.m, right? So you want to save 8 p.m, right? So whatever changes, and during these changes, so you have the log also, you have log, right? Hello,
Mhm.
you are getting my point, right? So whatever changes have been done, you consider only the log of that up to that timestamp, right? So that is the backup. Log means every record has, it has every record, right? So whatever you have changes done to changes done, right? You consider only up to that timestamp, right? Hence the log base log. You are getting my point.
No, actually no.
Okay. Okay, let me make this point. Suppose up to 8 points, there is one instance of your database, right?
Mm-hmm.
After that, you making the changes in the database, that is also in the log record also you have.
Mm-hmm.
Okay. So if whatever changes made to this DB means database, you consider only up to that timestamp of the log records, you then you got the original data, what backup you have done, right?
So that means
I'm
you are saying there is some mechanism when you take a backup, it puts in some kind of a log file with some timestamp.
yeah. I'm just want to give you some high level idea of that.
Mm-hmm.
And also one thing I also like to mention is the whatever you said is the commit. So here we discuss about the ideal cases, right? So commit, you whenever the commit is mentioned, right? So you have the ideal case, you have to suppose to think about that if commit command is happened or trigger, right? So you means it have changes the value in the database, original database, right? So you have to only deal about the ideal case.
Yeah, but the thing is that, like, since we have like till week 11, right? We have
Yeah.
seen that logical layer, your view layer, and also in the storage layer, right?
Yeah.
So now, if we take a very holistic view, that your storage layer is basically interacting with the operating system. Now,
Okay.
everything, whatever you are doing, that scheduling, right? That scheduling is basically what you are doing at the operating system level, right?
Yeah.
Now, the thing is that whenever we are talking about these
Okay.
failures may not be necessarily like only for a what I say, like interrupts. It is not only because of an interrupt,
Yeah.
right? It might be
Yeah.
because of some other reason also. So if there is anything like which are atomic operations, okay, so operating system guarantees that either that entire block will happen or nothing will happen.
Yeah. So let me tell you in this way. Suppose there is a 10 instruction, right?
Hmm.
Okay. Up to the 10 instruction got successfully executed, then if there is a commit means, after that the commit means, so whatever 10 instruction got executed, then we call as the commit, right?
That means it is atomic, you are saying.
Yeah,
Yeah,
that
that makes sense actually. If it is atomic, then of course, like operating system will honor that guy.
right.
The problem comes if it
And
is not atomic.
no, that is the at the last, whatever's the ins, if you consider anything as the atomic means, we combines things about means whole things. If 5 instruction are there, so at the end of the 5th instruction, then you consider that as the commit. After got successfully executed, means updated the value in the database, then only consider that is a commit happened. Only then, so up to the final statement. Hello,
Yes, sir.
is it making sense? Hello.
Yeah, I'm still thinking actually.
So you are talking about only the atomic, right? Means atomic, not atomic, the commit, right?
See, when we started with transaction, right? One thing we
Okay.
noticed first is atomicity. What that atomicity is, basically that atomicity tells if some operation is atomic, then either it will happen or it will not happen. There is nothing partially happen, right?
Yeah.
That is atomicity. And
Okay.
since this any database, it has to be ACID compliant, otherwise that database cannot be used in production. Okay,
Yeah. Okay.
correct. Now the point is, if I draw that in that same line, if commit is not atomic, that means commit can partially happen. That exactly that doesn't make much sense, right?
Yeah.
So
That is
from
not.
that angle, I was trying to ask this, because it might so happen that commit is actually writing more than one information from buffer to disk.
No, that is not this means. If any instruction commit means all the changes in the buffer that has to be happen in the database. If in middle got some failure happen, then also you have to redo again.
Then yes, that means it has to fail.
Yeah.
Right.
Okay. So then yeah. Is it clear now?
Yeah, it is clear, but still probably I'll ask a question in Discord. The relation between this log file and this commit operation, because this commit, whenever you are writing that commit in the log file, right?
Okay.
When you are writing that commit in the log file, that is a very crucial statement, because before that I will if something I get a commit, but you are saying that okay, commit will happen only after everything has been flushed to the disk. In that
Yeah.
circumstances, that commit will not make any problem. Okay, understood.
So, and one thing I also like to mention, you are talking about the interbank transaction, right?
Which transaction, sir? Interbank.
Interbank transaction, right?
Right.
Yeah. So I think that is the not the problem of the database transaction, right? So every bank maintains the one their own database, right? So for that interbank transaction, that is the banker agree with some RBI, right? So they are maintained by one system called, I don't remember the system. Suppose NEFT, you heard about the NEFT, right? NEFT
NEFT,
system,
yes.
and yeah,
Mm-hmm.
and the so RTGS also, there is one RTGS. So these systems are taking care of this interbank transaction. So you can think about, now I also giving the high level idea of that. So if possible, that's the all the bank are agree with the interbank transaction. So RBI, suppose RBI maintain one database, may be possible, right? Of all the bank, hence they maintains the whatever the real time status of all the bank account of each bank, right?
No,
So
I
I'll
don't
just
think like RBI
clear.
will maintain that granularity.
It is this interbank all transaction. It has to go through a mandatorily. It has to go through a gateway. Okay, that is the norm set, because one bank cannot give access to its internal database to any other bank. They will not give, because there is security concerns, like some other authorization, all those things will happen. So everything will happen through only a gateway, and that happens through the messaging system, wherein one bank will send a request, then the request will be answered, then the transaction statement will be sent. Like that, there is a sequence of messaging system. Through that only it will happen. Okay, there is nothing like one bank is accessing other bank database and performing a transaction over there or performing a commit. It doesn't happen.
so yeah, actually I means Rajiv, that is a different kind of problem. So
Yes, I think I need to little bit study on that and about that payment gateway and find out like what is that messaging system.
yeah,
Okay.
okay. I hope that's it. We
Okay, sir.
can
Thank
wind
you.
up the session.
Yeah.
Thank you. Thank you.
Thank you, everyone.
Thank you, sir.
Thank you all.
Thank you, ma'am.